Hello and welcome to Physics Ka Doctor. My name is Dr. Ghanshyam Tejani and let's start class 11 in which physics and we are targeting vector as a math tool. So we need a vector in many of the sessions and therefore let us understand vector with a full detail. What are we going to consider here? We will be considering everything about vector. That will also include how vectors are added, how that can be subtracted, how there is a multiplication with the use of dot and cross product, and this is to be done with a lots of numericals. So stay with me. Let's start. Let us understand first what is scalar. Definition says that a physical quantity which requires magnitude alone is known as scalar. A physical quantity which requires magnitude, it is known as a scalar. Say for example, let us consider I have a product inside a box, and this product name is A, and it is having mass 10 kilogram. So here, to show its physical quantity, what I required, I just need number which is a magnitude 10 kilogram plus its unit. So these two are sufficient to show a scalar quantity. I do not need a direction. If we specifically say about scalar, so we don't need any direction. Let us consider few examples of scalar. First, it is a distance. In one of the topic, distance and displacement, we understand how it works. Say for example, Arpita, right, is asked to go to her school. Say for example, this is a place where she lives, so that is her house, and somewhere here, her school, it is there located. And as per her mother's thought that she should go from home to school directly. And say, for example, this is somewhat distance where school is located at some straight distance. Fine. But she has some work at ice cream parlor, and you understand, right? What is the work? What happens? She is first visiting an ice cream parlor, and then she go to school. So here we can see there are two different possibilities. She may directly pick this way to reach her destination. So if it is a shortest one, if you see the direction, there is a shortest direction and the shortest distance, it is there. So that is known as displacement. But if she is moving with some other aspect, right? Ice cream. So here the path become a longer and that become distance. We already understand displacement and distance, what are the differences, as well as large number of examples were also solved, right? Now, a point is that a distance we mentioned in the example as a scalar. How it is a scalar? See, distance required only total. Say for example, this is 5 kilometer and that distance is 10 kilometer. So when we talk about distance, so total 5 plus 10 is equal to 15 kilometer. She traveled, if she travel with the ice cream parlor, then this is the distance 15 kilometers. In this case, she does not require any direction. But if she travel directly straight from home to the school, so at that time, say for example, this total distance from home to school in a straight path, 12 kilometers. So now this 12 kilometer become a displacement, and to travel with this displacement, she need a direction. She need a direction, right? So therefore, here become distance become scalar quantity where we just need a magnitude. We do not need any direction. Now let us understand second part, that is the speed. What is speed? What is speed? We already understand speed is equal to total distance travel divided by total time, or you can say time taken, right? It is taken time. So here, if we talk about speed, so we need to consider total distance. So in the case of distance, suppose she travel with this path with the parlor, so it become 15 kilometer, and in this travel, suppose she take 30-minute time. So 15 by 13, that becomes speed, right? And in the case of here, distance is a scalar quantity divided by time. Time is also a scalar quantity. See, we do not require any direction to present time, and therefore time is also a scalar quantity. Therefore, scalar quantity multiply or maybe a division of scalar quantity, it gives us a scalar quantity. Therefore, speed become a scalar quantity. Third one is the mass. The human mass, say for example, human mass is 60 kilogram. 60 kilogram in the direction of vertical, in the direction of maybe towards right hand, towards left hand, or vertical. It remains 60. There isn't any change. It does not possess any directional property. If I talk about weight, yes, of course, then it is towards gravity, towards earth. But otherwise, it does not possess any directional property. Therefore, mass is also a scalar quantity. Then time we already discussed, time is already a scalar quantity. Then the next is area. If you talk about area, what we need here? We need suppose length or height to measure area. Length, it is in terms of meter, and in terms of length, it is already a scalar quantity. We do not need any direction because it is just a distance. It is just a distance. Therefore, here scalar multiplied by scalar gives a scalar. And similar case is for volume. We just need one more addition of scalar, then it gives us a scalar quantity. And similar it is for the temperature and as well as time. We do not need direction, and therefore this all become a scalar quantity. There are a few more examples. Another is energy, work, power, specific heat, charge, potential. These all are also a scalar quantity. We will see how this become a scalar quantity, because work, when you talk about work, so there are some vector quantities in the multiplication. But for that, we need to understand vector multiplication in terms of dot product as well as in terms of cross product, right? Then only we'll understand that how this all items are a scalar quantity. One more thing is that a scalar quantity can be added, or you can say subtracted, or multiplication. This all things can be done with the use of simple algebra that we understand, that we already learned so many times, right? So no special learning is required for the scalar quantity. It is, we have been studying this one. Now second one, that is a vector quantity. So what it present, that a physical quantity which requires magnitude. It was already there in the scalar also, right? Here in terms of magnitude, plus we need a particular direction. Here we need magnitude plus a direction. If we take the similar example, if she take a path, in a particular direction, directly straight towards a school at a particular direction in the 12-kilometer distance, right? A shortest path if she is taking, that means that become vector. That become vector. And this is the why, this is why displacement is a vector. Displacement is a vector. We have few more examples for that vector. Let us understand one by one. So displacement is understood that it required magnitude, what distance we are traveling and in which direction the distance are traveled, right? So vector, it is requiring two quantity, magnitude as well as direction. Now what is velocity? What is velocity? So velocity is equal to displacement divided by total time, divided by time taken. In the case of speed, it was a distance divided by time. Here it is a displacement divided by time. And we know that displacement is a vector quantity and the time is a scalar quantity. If multiplication of vector with a scalar, or maybe vector division by scalar, so ultimately we will have a vector quantity. Remember this, right? Vector multiplied by a scalar quantity, it always gives us a vector quantity. We need direction in terms of velocity also. Therefore, velocity become a scalar quantity. Scalar? Is it scalar? No, it's not a scalar. It is a vector quantity. Then next is acceleration. What is acceleration? Acceleration, we know that acceleration is equal to velocity divided by time. So what is velocity? Velocity we already seen. It's a vector quantity. Time is a scalar quantity. So acceleration become vector quantity. Therefore, acceleration become vector quantity. Remember that word. The next is a momentum. What is momentum? Momentum is equal to mass multiplied by velocity. Mass, we have seen mass, it is here. Mass is a scalar quantity and the velocity we already proved. It's a vector quantity. So therefore, vector multiplied by scalar, that gives us vector quantity. That's where momentum become a vector quantity. Next is force. Next is force. What is force? Force is equal to mass multiplied by acceleration. We know from the Newton's law. What about mass? Again, it's a mass. It's a scalar quantity. What about acceleration? It's a vector quantity. So ultimately, force become vector quantity. And similar, a brother of force, it become weight, mass multiplied by gravitational acceleration. So G and A both are brothers, and therefore W become vector. Right. Similar, you can have electric field, magnetic field, etc. Right. I simply suggest that you, why don't you solve this remaining quantity? Why these are in the vector group, and comment in the section below. Now let us start. What is vector? So see, vectors are represented with a bold or arrow bars. In the textbook, you can see vectors are having a bold letter. It can be a capital letter or small letter, it is okay. Above this, you can have A, it is called as a bar, or you can have B as an arrow, or you can also call this as a bar, or it can have a dark bold letter for that. So these three are used to represent a vector. That means it is having magnitude as well as it is having some direction. Next is absolute magnitude of vector. That means only if you are talking about magnitude, so it is represented by either this letter A, or we can use this is mode of A, mode of A. These two lines are known as mode, or you can have mode with the bar symbol also, that can be utilized. With the bar symbol also, that is can be utilized. The next, if you talk about geometrically, vector is represented by a line with an arrow. It is represented, you can see here on the top portion, it is represented by a line, a straight line with some arrow, so that arrow indicates direction of vector. Arrow, this arrow head. If you talk about this portion, that is known as head. This portion is known as tail, and this length of this arrow shows a magnitude of vector. Once again, if you see the top portion here, it is head. This is known as tail, and the length of this vector, it shows magnitude of this vector. And if we are showing this in a plane, if we are showing vector in a plane, say for example x, y, we consider here as a plane, and it is making some angle with x-axis, we directly assume that this is vector A, it is having head, it is having tail, and tail makes an angle, we call it a theta with x, with respect to x. So this is a simple representation of a vector. Simple representation of a vector. In terms of a symbolic form, we already discussed A bar, or you can say B arrow, C bar. And if it is not without bar, so it is a scalar quantity, or simply we can say a magnitude. So difference, when we talk about a vector, so there must be some sign, say for example A bar or A arrow, or it should be bold, or it should be a bold, so that become a vector. That is a symbol of vector. And if it is not there, if it is just A B C, that means it just show a magnitude, or it is just showing a scalar quantity. So this is the difference between vector and a scalar. Graphically, if we talk about that, so graphically vector is represented by straight line. This is a straight line, and having some magnitude, that length is presented by magnitude, and this arrowhead, it is present direction. So graphically we have to show its magnitude as well as direction, both we have to show. How? So in the case of graphical, say for example, if we want to represent a force 5 Newton acting 45-degree north of east. So these are the steps. First, take direction coordinates. First, we need to understand direction coordinates. For example, if we drew here direction coordinate x, y, or you can say here it is mentioned NEWS, right? This is direction coordinate, come from news, or news is mentioned from this, right? So first we need to have this direction coordinate. We need some reference to show a vector. Then we need to have a scale. We need to have a scale. Say for example, distance is given 5 Newton. So we can convert like 5 Newton is equal to 5 centimeter. We need to represent in terms of centimeter meter like that only, right? So on a graph paper, on a paper, we can draw with the use of length only. So first is we need a direction. So this is the first. Then we need to have a scale that is mentioned here. We can take as per requirement and then draw a line. Draw a line, draw a line, draw a line, right? At a given direction, at given angle theta, and with magnitude. This is the distance we need to take as a magnitude. The length is to be magnitude. So this is a direction. This is very simple method to present any vector for any kind of calculation. This is simple, very simple part. So here angle between two vectors. Angle between two vectors is to be smaller of two angles. How to consider angle between two vectors? Say for example here the drawing is given vector A and B. There are possibilities here. This is the smaller, and if we take outside of this part, so it become bigger. So when we talk about angle of vector, we can only go with this smaller vector. A bigger vector cannot be considered. A bigger part cannot be considered. So it is mentioned here angle between two vector is to be smaller of the two angles between the vectors when they are placed tail to tail, when they are placed tail to tail by displacing either of the vectors parallel to itself. So here suppose two vectors are given, say for example a vector and here it is b vector. So that has to be moved like that. This tail to tail contact should be there, and we cannot change angle. We cannot change angle of this vector. If you see the first drawing, it is already having a tail to tail connection, but in the drawing number 2, the connection is not with the tail. So what we need to do, we have to move this vector on the other direction, or we may extend this vector, and we can measure this angle as a theta, right? In the third case, if you see vector A is here, vector B is here, so there is a head and the tail connection, head and tail connection, this one. So in this case, we need to move vector B to the opposite side, and therefore that must be a tail connection. Of tail to tail is mandatory here. It cannot work, otherwise it cannot work. So here we need to consider a smaller angle. We understand first it is a smaller angle is to be considered, and second is there must be connection of tail to tail. If it is not, then we need to move. Let's have example number 1. So three vectors A, B and C are shown in the figure. We can see here that is a vector A makes 30 degree with x, vector B, it makes 30 degree with x in the opposite direction, and C makes 45 degree x below the x line. Fine. Find angle between A and B. So we need to find angle between vector A and vector B, then B and C, then B and C, B and C, and C and A. These three are required. So we already studied rules. What we need to do? We just need, first we need reference x, y. Then we need to put this A bar with magnitude and that angle, same angle 30. Then what is next? We need to put this B bar here. This is a B, at angle of 30 degree opposite side, as well as the 45 last one, it is here at 45 degree. This become 45, and that is a C bar, right? And then we can directly solve it. So we can get this. So we can say a distance angle between A and B, 30 plus 30, that become 60 degree. So first answer is 60 degree. Then B and C, B and C, B and C, B and C, that become 15 degree. A smaller angle we need to consider, right? By default we used to take smaller angle, but here there is a rule. And A to C, that become 30 plus 30 plus 15, that become 75, right? 75. So that is, these are our answers, right? Seems very simple. I think you are getting some feel of physics. Great. Now, vector, let us understand different types of vector first. Now, first it is mentioned here, negative of vector means negative vector. It implies vector of same magnitude. There is no change in terms of magnitude. That's why you can see length is equal, but only direction is opposite, right? So for example, I'm applying some force 5 kilonewton, and there is some reaction force in the 5 minus 5 kilonewton. So both are equal and opposite. The direction, reverse direction, that is a negative vector. Just like A, when we just multiply by minus 1, it is very similar to that algebraic formula. Then is unit vector might be something new for you. See, you know that unit or unity simply just representing one. It representing one. Say for example, distance, our favorite, let's take Delhi to Bombay is equal to 1123 kilometer. But if I take unit, its unit is kilometer. Its unit is kilometer. Then it's 1 kilometer if you take. Will be precise, right? So similar case is applicable here. In the case of unit vector, where vector is having magnitude is equal to 1, or simply can say no magnitude, is having magnitude is equal to 1, or simply we can say no magnitude. That means it's a vector that should be divided by its magnitude. Its magnitude, that means mode of a. So here a cap is used to represent unit vector. A small cap is used to represent its unity or unit vector. Simply you can say a cap unit vector is equal to a bar, that is a full vector, divided by its mode. Or we can write also a bar is equal to a magnitude multiplied by its mode. Like that we can work out. Let's move. Now next is zero vector. Zero vector means what? Its magnitude is 0. Right? Magnitude, there is no magnitude. That means it's a zero vector. Why it is required? You just think and answer me why zero vector is required. Tell me why 0 kilogram is required. 0 kilogram is nothing. No, wait. Similar cases here, zero vector, but it is required in terms of physics. And it is also known as null vector, right? If you have some question during your examination and it is mentioned null vector, that means it's a 0, and its direction is arbitrary. That means random. It is not having even direction, you can say, or it is having random direction. It can have x, y, z, whatever. So it is having a direction which is arbitrary, means random. Then is next is equality of vectors. When can we say vectors are equal? When can we say vectors are equal? We call say if a is equal to 2, b is equal to 2, then we can say a is equal to b, right, in terms of scalar product. But what about vector? In case of vector, you need two things. One is magnitude should be equal, that we have seen here. and as well as it should have a similar direction. There is no change in the direction is permitted. So say for example, A is having this direction, say for example 60-degree angle with X, C is having 60-degree angle, B is also having 60-degree angle with X, and else having A is having 3, B is having 3, C is having 3, right? So in this case, it seems like parallel, that is okay, but two things should be there. One is magnitude and second is direction should be same. There should be no difference in terms of magnitude and the direction. In this case, we can call vectors are equal. So here it's unit vector. These are also equal. Its magnitude is also equal. And this cap is also representing direction, right? Unit vector is also representing direction. Therefore, that is talking about direction, and these values are talking about its mode or magnitude. Let's move. Next, it is a collinear vector. What did it say? Two vectors are collinear, then one can be expressed in the form of other. If two vectors are collinear, right? If two vectors are collinear, that means both are in the same similar line or maybe in the parallel. Say for example, this is having 10 in the direction, it is similar direction. Say for example, A cap, and it is having 1 direction is same, A cap. So both can be represented just directly. Say for example, it is A and that is B. So you can say A is equal to vector A is equal to lambda, means 10 times this P vector, right? So here in case of collinear, line of action of all the vectors act along the same direction, it is mentioned. Line of action, a bigger vector or a smaller vector, whatever, all are in the same direction, and here there is a magnitude is only difference, right? So we can have multiplication in terms of constant, and that vector just become this many times. Otherwise, its direction is similar, and it is in the same line. Collinear, it is having on the same line. So I think you must have understood with what is collinear. Sometimes a like word is used when the direction is similar. Next is co-initial or concurrent. By the co-initial, from the name in itself, you can judge, but concurrent is also a word that is used for the similar case. What it says that the line of action of all the forces in a system passes through a single point. If one force it is here, or you can say one vector it is here, another vector is moving in this direction. In the forces, or you can say vector, we can write here, right? If all are passes through a single point, that means they are co-initial, or you can say concurrent. Or you can have another drawing, all are initiating with one single point, all are initiating with a one single point and going in this direction, another is direction, right? So we can say them as a concurrent or co-initial vector. Second is coplanar. Coplanar means all vectors are in a single plane. Say for example, this is my xy plane, this is my xy plane, this is my xy plane, and all are on the plane, xy plane. All the vectors are in a single plane. All the vectors are in a single plane that are known as coplanar. We will see examples for that also. You just understand as of now the simple meaning of that part. So not if the frame of reference is translated. That is a specific note for the every part. Suppose initially S and this is B vector. If this entire vector S and B is shifted towards some angle, right? S and B are having the similar angle, whatever it is having initially. But if it is moved to some Other angle, its property remain constant. There is no change in the terms of property. If the entire every all the vectors are changed, then it is not having change in terms of vector properties, right? But all the vectors has to be changed, right? Otherwise there will be change in terms of magnitude. So we will understand this all in the very detail by taking examples. It is the best method to take it. Now let us understand system of vector by taking various examples. So first we understand collinear. So line of action of all the vectors are in the same line. And the example is given here, tug of war. I think you must have played a tug of war where a rope, right? And on the both the side, group of people, right? They pull on the opposite side and right. So all the forces, all the hands are on this tug of war are having in the similar direction, on the similar direction, single direction, in the direction of rope, in the direction of rope. So this party, this side A and this side B, right? So A is apple side is all are in the same direction, all are in the same direction, and the B side are having all on the opposite direction. So all the line of action take place in a single line. Line of action take place in a single line. So that become collinear. That means from the word also we understand, right? All forces are in a single direction. Second is coplanar. All the vectors are parallel to each other. So what is mentioned? One is word is coplanar and second word is mentioned parallel. Coplanar, that means, say for example, if we draw x and y plane, so all are should be in the same plane. And second is parallel, that means angle should be equal, right? This angle theta for all the vectors must be equal. For example, force is acting on a beam, it is just a horizontal bar, and this is a bench. Simple, consider we stand here on this bench, about three people are there. So all are on a single plane and all are parallel. Vertical forces are there and all are in a parallel path. Simple to understood. The next is coplanar. The first word is coplanar. That means what? Are in a single plane, x and y. Second is parallel. So we understand, right? What angles must be equal among all of this vector, and the like. Another word is used, like. Like, that means see the arrow direction. Arrow direction must be same. Arrow direction must be same. Right? Magnitude can be different, but arrow direction must be same. So three things are mentioned. One is coplanar, means single plane, xy. Like means all the direction should be in the same side, similar side. And the parallel, we know that angle should be equal for all. Angle should be equal for all. So example, weight of a stationary train on a rail. Say for example, this is a rail track and there is a track. So all are having single direction, downward direction, all are having load downward direction, and all are parallel and all are in single plane. Comment me more examples on all of this. The next is coplanar. Again mention coplanar means single plane xy. What about concurrent? Concurrent means pointing. All the forces are pointing, or you can say passing through a single point. All must passes through a single point. Right. So line of action of all vector passes through a single point, and forces on a road resting against wall. Forces on a road, say for example, this is a wall and there is some kind of wall. So this is somewhat road. It is resting. So whatever forces are reaction forces may be there, or downward forces may be there, friction forces may be there, whatever. They all are pointing at the similar place. Similar place. You will be solving so many examples on it. Don't worry. Then next is coplanar, non-concurrent. Tell me, what about coplanar? Coplanar, we understand XY plane, and non-concurrent means all of are not pointing at a single point. All of are not meeting at a single point. Let's for example, the weight of vehicle on a thin bridge, weight of vehicle on a thin bridge, or you can take any other weight, any other consideration when the detail we are considering. So it is having non-concurrent, means all the forces are not meeting at the similar point. Say for example, this is a bridge. One vehicle is here, another vehicle may be having some angle, some kind of load, it is having some movement. So all are not meeting, any of them are not meeting. Non-coplanar, that means not about 2D, but this is going to be a 3D, not in a single plane. That means loads are not just associated with X and Y, but it is also with Z. Again, non-coplanar, X, Y not sufficient, it is with the Z also. And parallel, that we understand, right? It is parallel, that we understand. Tree. Example of weight, tree. Then weight of branches, benches in a classroom. There are benches on a classroom 3D drawing. One bench is located here, second located here, three. Right? So there are three-dimensional parts are there, and you can find plenty of other examples also. Non-coplanar, that means it's a 3D, and concurrent. That means meeting at the single point. Tripod. Yeah, we used to record with the use of this tripod, and we mount camera on it. The tripod, all the weights see here are in the three dimension. One force is here, second force, third force, and the fourth force. All are meeting at a single point. So that become non-coplanar. That means it's a 3D and concurrent, meeting at a single point. Then last is non-coplanar and non-concurrent. Non-coplanar and non-concurrent. Non-coplanar, that means 3D, and non-concurrent, that means not meeting at a single point. And action you can take, there are large number of examples you can find. Forces acting on a moving buses may be there. One force may be on the ground, vertical forces, friction forces can be there, wind forces can be there. There are lots of possible, right? So what I suggest you, that you do not learn the entire chapter at one go. You break the chapter into 4-5 session. Every day you just take small portion of this part, and then only it is going to be understood by you, right? You cannot learn the entire chapter in one go. Remember that. Let us solve an example. See, solution of example is suggest. Example is given here of physical quantity mass 3 kg is multiplied by a factor A, that is from acceleration, such that force is equal to mass multiplied by acceleration. Find the magnitude and direction of F if A bar is equal to 3 meter per second square eastward, and second case A bar is equal to minus 4 meter per second square. Now to solve this kind of questions, you must know the direction. And this is, you just remember by using this line NEW as views. Knowledge of direction is important to solve this kind of problem, right? You just understand that NEW as, you just make NEW as, and start with NEW as. You just make this kind of news. And so the question is like that: A bar is towards eastward, A bar is going towards eastward. So this is A bar towards east. That is the value of A bar. You can take 3 as a magnitude. And we know the equation is equal to F is equal to mass multiplied by acceleration. Mass is a scalar quantity, A is the acceleration, is a vector quantity. And it ultimately gives us scalar multiplied by vector. We understand that it gives us a vector quantity. And that's why this knowledge is required. So 3 kilogram put here, 3 kilogram, and answer is 3 in the direction of east. In the direction of east. So answer is 9, and the direction remains same. There is no change in the same direction, so direction will be same. Force is applied in this direction and the answer is also in the same direction. The next question, it is A is equal to minus 4 meter per second square. A bar, it is here now minus, so direction is negative. Put the similar value here, answer is 12. Northward, if you talk about northward direction, this is the north direction, is upward direction. But our answer is negative. So here we need a negative vector. And to just show a negative vector, we just need to multiply by minus 1. It gives us plus 12. And the opposite direction is south. Opposite direction is south, right? So here negative vector is useful. Right? We already learned what is meaning of negative vector. Now next is, let us do addition of vectors. So there is a rule called triangle rule of addition. What is 10? If two vectors are represented in magnitude and direction by the two sides of triangle taken in the same order, then their resultant is represented in magnitude and direction by the third side of the triangle taken in the opposite order. So what it mentioned that this is vector number A, say for example A, it is starting from tail and it is going to meet another vector in terms of tail and head. That means same order. First tail, then head. Order is same, right? So the third vector gives its resultant, and that should be order should be opposite. That means here it is meeting head to head, not head to tail. If you see here order how it works, again this is tail and this is head of vector AB, or simply we can say A vector. So this is head, it is meeting tail, but here head meets head, right? So it is the opposite order, therefore this AD gives us, it's a vector solution. That means AC bar plus CD bar is equal to AD bar. Just if head to head meet, you just use equal sign. If there is a head to tail, so that means plus. That means it is a plus. That is plus. There is one more understanding. Head to head meeting, for that negative sign used, but we will understand this later, right? Don't worry as of now. As of now, what you do? Just A, B vector, if head to tail meets, so plus CD vector, if head to head meets, equal AD vector, right? So this is triangle rule of addition. Let us understand with more detail with steps. So what it says, step number 1, suppose there are two vectors are given, AB and CD are given. So tail of one vector, right? Tail of one vector coincide with the head of other. So you just need to redraw this. Say for example, AB it is mentioned here, and you just move this CD vector such that this is the head and tail. Tail of the next vector should be on the head of the first vector, and this angle of CD should not change, it remains same, theta, it should be theta. You cannot change angle, right? Do not change angle of this. So ultimately what it gives? AB, this vector, AB plus this vector, CD is equal to resultant AB. Right? What? True? First A to B, then CD vector, so it becomes C to D. Then join this tail, join this tail with the head. Join this tail with the head. So this AD gives a resultant of this two vector. Right. So this new vector, it is the sum of two vectors. First, what we need to do? We just need to replace this vector such that CD, just you need to move this here. So this becomes CD, and this just join tail with this head, the direction of head. So this AD gives resultant. AD gives resultant. Very simple. It is very simple. Let us have an example based on this. Three vectors A, B, B, C, and C are presented by three sides of triangle as shown in the figure. Show that AB plus BC plus C is 0. We don't know. Let's see. So from the triangle of law, what we understand, say for example, if it is meeting head with the tail, right? So whenever there is this condition, so what we use? We use AB. Say for example, this is A, this is B, this is C. So what we use? This is C, right? So here AB plus BC from the rule of triangle. And then we know that from the rule of triangle, there is a, if you join this tail with the head of this, so that becomes, you just need to sign AC. If you see here, there is an opposite sign. AB is okay, but C is opposite. Just if I just want to reverse this sign, so what it should be? AC in terms of, it should be negative. It should be negative. Right? It should be negative side. So here, what we see here, AB plus BC, AB plus BC, in the terms of opposite side, if we take, then become AC. AC, if we take the same side, then it becomes AC, and we need to reverse this direction as per triangle law. This direction should be head, should mix on the opposite side. So just to negative, what we require, we just need a negative vector multiplied by minus. So AC is equal to minus CA. Opposite vector is equal to minus. So just convert this into direction, opposite direction. It is there. Put the value here. Put the value here. AB plus BC is equal to minus CA. CA is an opposite side, so it becomes this is the side. It's very simple. See, AC and CA both are different thing, right? If you see AC, that means it is starting from A and heading towards C. This is C and this is A. If you write CA, that means it is starting from C and head is A. See, remember this. It is going to be very useful for you how it to be constructed. Now, example question number 1, that is, you try it yourself. This is your homework problem. So find the net displacement of a particle from its starting point. It is undergoes two successive displacement. S1 20 meter 37 north of west. So we can say north of west 37, somewhat about this angle 37 north of east, and this magnitude you can take 20, and then west S2 is equal to 50 north of east north of east in this direction. In this direction the angle is somewhat about 53, and this is something about 50. Solve this by yourself. This is your homework problem, right? Text me your answer in the comment box. Second is find the magnitude B, the direction of resultant A, if B makes angle 37 and C makes angle 53 degree with x-axis, and A has magnitude is equal to 10. Wow. And C has 5. C has 5. So another question it is that what is mentioned here? B makes angle 37, C makes angle 53 with A. B makes angle 37, C makes 57 with A, and magnitudes are given for A and C 5. Yeah, comment me your answer. This is your homework problem and comment me answer. If you don't get the answer, let me know. I can solve. I will solve it. Right? But I think you can do it. You can do it. Question number 3. A boy moves 5 meters south, then 3 meters in the direction of 30 degree of north. Find the resultant displacement using graph. So these 3 examples you solve. Remember that unsolved example, if you solve, then it boosts confidence and the correct answer brings happiness. So text me correct answer. By just watching this video or maybe someone else's video, it never work. You have to try, you have to do it by yourself, then only it is possible. Now next is another law, polygon. Polygon, that you understand that more than one side is having polygon. So it is just an extension of the previous law, which is a triangle law. So here, if A and B are given, A and B are given, A and B are given here. So join, this is A vector, join tail of next vector, and this gives what it gives resultant. It gives A bar plus B bar. It gives A bar plus B bar. Now next is what? Join C vector from this ending with the same direction, C vector. So this gives A plus B plus C vector. And then what next? D. Join this D. Join this D. Very simple, isn't it? D. Then it gives A bar plus B bar plus C bar. So this is polygon, nothing else. This is polygon, nothing else. This is just join A with B with C with D, and this resultant gives the final resultant of all the forces, final resultant of all the forces. Very simple. You should use the graphical method. This is the method, very simple method it is there, and this last vector, it gives us a resultant vector. So ultimately P is equal to A plus B, B plus C, right? Whatever you just change, answer is similar, right? So it is also known as associative law. That means rearranging of position. You can see A plus B or B plus A plus C plus D, whatever you arrange, right? Answer remains similar. There isn't any change in the answer. So you also understand this term associative law. It says that rearranging of the parentheses in an expression will not change the result. There isn't any change of result if we change its a position. You can write here B plus A plus B plus C. It remains similar. Even though I can have, this is A direction, then I can have C direction, then I can have D direction, and the last I can have B direction. Then this also resultant will be same. There isn't any change. If you change its position, right, there isn't any worry about it. But you have to always consider that head should meet tail. HT, that you have to remember. Head should meet tail. Otherwise, there will be a wrong answer. Parallelogram, it is a very easy task, the vector. So this is your homework problem. Buddy, you solve it. Determine the resultant of F1, F2, F3. What is mentioned here? F1 is 800 Newton. So what you do? Like that. Let me see here. May not be visible. So F1, take magnitude. F1 take is equal to 8 centimeter with the angle Similar 40-degree, fine. Then what you do, you can take this 12 centimeter in this direction, F3, or you can take F2 also, and then take this 100, right? That means 10 centimeter. This was 12 centimeter, and this is your resultant. This is your resultant. Head should match head and head connection gives us resultant. So solve and comment me answer. In the addition of vector, there is a one more law that is known as parallelogram law of addition. What it stands? If the two vectors are presented in magnitude and direction by two adjacent sides of a parallelogram drawn from a point, then their resultant is presented in magnitude and direction by the diagonal of a parallelogram passing through that point. What it stands that suppose this is vector number A and this is vector number B are presented in terms of parallelogram. So this shape is known as parallelogram, and the B, it is equally drawn here in this case, and A, the distance, this is distance is equal to A, right? And this R from O to P, that is known as diagonal. So the diagonal it gives A bar plus B bar. It gives resultant. And this beta gives us angle with respect to A. So this is something about flow of parallelogram. Let us understand with more detail with the steps. You understand that. So this law, it is used for adding like two vectors, and it is also extension of triangle law. So what is step? First, it is just draw A and B in such case that here tail should meet with the tail. There is some difference, right? Tail should connect with the tail, and then draw a parallelogram. So this line is parallel to B bar, this line is parallel to A bar, and that gives us a parallelogram. Then join this diagonal AC, join this diagonal AC, right? All heads are meeting here, So this AC gives us resultant. Very simple. So AC is equal to A bar plus B bar, or you can say B bar plus A bar. That is commutative law. That means order is not important. You can have B plus A is equal to A plus B. In algebra also the similar rule is applicable. Then the angle between two vector is the angle between their positive direction. See, we need to take positive direction. We cannot take it's a negative direction of AB. That angle must be with the positive direction. We cannot take direction negative in this case. And another statement, not to a vector, only a vector of the similar type can be added. Different types of vector cannot be added. You have to remember that part. The same physical quantity that has to be added, and the result are also a similar quantity. A similar physical quantity can only be added. If there is a force, then force plus force can be added. If there is a force plus you talk about displacement, force plus displacement cannot be added. Right? Similar. Rule is very simple. It is known to everyone. Let us see parallelogram of law. Let us assume that theta, it is the angle of between A and B, and the A bar and B bar are, you can say, vector, right? So we know that simple. If we extend this line, draw a vertical line and give name B, and this is B, give E name. So that AD, that is our distance, AD, it is a triangle, and here it is 90-degree angle. AD This is E. So from the Pythagoras, can we say AD square is equal to A square plus D, or you can say DE square? Yes, of course we can. We can. Of course we can. There isn't any issue with this. Then this AE, this is AE. Can I say A is equal to AB plus BE? Yeah, of course we can. There isn't any issue. Why not? Yes, you should. Then we have this distance AB. AB. This is our vector A. This is our vector A. And the opposite side, if you just go with this distance. So see this vector, it is a B bar. This vector is a B bar. So can we derive B from the law of triangle? What it says that? What it says that cos theta is equal to nearer side divided by its hypotenuse. So it is B bar. So BE is equal to B cos theta. Similar here, this is A. So then become A. We may write bar if you want to. Then B bar cos theta. This is B bar cos theta. Similar, we need a DE component. We need a DE component. So what happened? If one is sin theta, other should be cos theta, or one is cos theta, other should be sin theta. So it becomes B bar cos theta. Simple trigonometry, already studied this bar, and this line becomes B bar theta, and this is not correct. We correct it. This becomes V bar theta. Great. So this is DE from that, right? From that, we just use a trigonometry for that. Next is AD. So just expanding this, A square plus 2AB cos theta plus B square cos square theta. So this is expansion of this bracket, and this is B square sin square theta. Let's rearrange this. Can we write this A square plus this B square cos theta? So we can take B as a common. B square is equal to sin square theta plus cos theta. What is this? 1. Sin square theta plus cos square theta is 1. It is well known. So that become A square plus B square is equal to plus 2AB cos theta, and therefore AD resultant is equal to A square plus B square plus 2AB cos theta. So this equation you have to remember when you use parallelogram law of addition. An angle of, if you just wanted to have this angle with respect to A, so we know that the opposite side, or you can say perpendicular side, divided by nearer side. So it becomes B sin theta. D is equal to B sin theta, and A is equal to A plus B cos theta. So this gives us angle with respect to vector A. Right. So that we need to understand. This is very simple theorem. Here R become maximum. When R become maximum, theta it become maximum. So maximum theta is possible 1. So at that time, when you take 1, so A square plus B square plus 2AB is equal to A plus B square, and therefore R is equal to A plus B. When it happened, right? When it happened, right? Theta is equal to 0. So that means both vectors are having in the same direction. Both the vectors are in the having similar direction. Then only this thing can happen. So theta is equal to 0, and R can be minimum. So minus 1. Opposite can be there. A minus B, or sometimes you can take cos theta is equal to 0 also. We can take, so A square plus B square in the root, and when there is a 90-degree angle, this happen. So let's move in the another part. Here the two equations are given, right? If A bar is equal to B bar, that means if both the vectors are having equal vectors and the angle is theta. So can you prove this with the use of trigonometry, right? And if it is 90 minus theta, 90 minus theta, we will see what is 90 minus theta, just wait. But you prove this too and comment me your solution. Comment me solution. That's our example. So example, it is there two vectors of 10 unit and 5 units make an angle 120 degree with each other. Find the magnitude and angle of resultant. So we know that given data A is equal to 10, B is equal to 5, theta is equal to 120 degree. Put equation here, R A square plus B square plus 2AB cos theta. The put value, this A is 10, B is 5 and theta is 120. So R is equal to 5 root 3 and angle of resultant vector alpha equation we know alpha is equal to B sin theta divided by A plus B cos theta. So that gives us the resultant angle of that solution. Very simple. Alpha is 30 degree. Alpha is 30 degree. Now let's understand subtraction of vectors and the parallelogram law of subtraction is useful here. In the previous case we studied, this is a vector A, a vector B and a smaller angle in between, that is known as theta, right? An outer angle that cannot be considered as a angle of vector. So inner angle only is required to consider. Now when we consider here A minus B, if we need here our solution A minus B, that means it's a case of subtraction. We just need to change the direction of vector, one of the vector. Let us change the direction of B. That means it become a negative vector. That means it become a negative vector. And then we need its angle. We need its angle. This angle we require. This angle we require. How to calculate this angle? We already studied so many times that opposite angles are equal and this total angle, it is 180. Therefore that internal angle become 100 minus this theta, right? So here that internal angle become 100 minus theta. Now it's a problem is solved. Now there is nothing. So angle between A bar and minus B bar will be 180 minus theta, that we already seen here. And now we have equation resultant is equal to A square plus B square plus 2AB cos theta. But here theta is 180 minus theta. 180 minus theta. 180 minus theta become minus cos theta. It becomes minus cos theta. So this is final equation. When A minus B, this value should be a negative one. Similar angle, if you wanted to have angle alpha with respect to A bar, so that become B sin theta divided by A plus B cos theta. But theta here it is 180 minus theta. Put the value here. Sin 180 minus theta becomes sin theta and cos 180 minus theta become minus cos theta. So this is the equation of a resultant with respect to A, and similarly resultant with respect to B, that means beta, this angle, it is A sin theta B minus A cos theta. It is like that. I think it is very simple and understood. Now let us take an example. Here it is two vectors of equal magnitude. Two are at an angle 60 degree to each other. Find magnitude of their sum and differences. So A and B both are having magnitude 2. Angle is theta 60 degree. So we know that equation. A bar plus B bar is equal to under root, right, A square plus B square plus 2AB cos theta. This is the resultant vector. Let us put A is equal to 2, B is equal to 2 and theta is equal to 60. So cos theta cos 60 is 1 half. So answer is A plus B is 2 root 3. And similar for A minus B. Only change is reported here. This become minus. A square plus B square minus 2AB cos theta. Resultant become 2. Resultant become 2. Let's have another example. Example number 6. Find A plus B and A minus B in the diagram shown in the figure. Given A is equal to 4, B is equal to 3. So data is given, theta is 60 degree is given. Very simple. We just need to put basic equation A bar plus B bar, that is resultant, under root A square plus B square plus 2AB cos theta. Put the values here and answer is 37. Answer is 37. Very simple. And the tan alpha, if we need angle of resultant with respect to A, so that become alpha B sin theta divided by A plus B cos theta. Put the values here. So tan alpha is equal to 0.472 and then it become 25.3 degree. Similar here, A minus B, the change is here. A square plus B square minus 2AB cos theta. Put the values here. So that become 13. That become 13. And tan alpha is equal to B sin theta divided by A minus B cos theta. Put the values here and you will get tan alpha is equal to 1.04 and alpha is equal to 14.1 degree. It is very simple. We are not spending much time on that because these examples are directly based on direct equation. You just need to remember this equation. Resultant, nothing else. Let's have example number 7. What is mentioned here? The following pairs of forces acts on a particle at an angle theta, which can have any value. So there are four options are given. The value can be 2n and 3n, and likewise B, C, D are given. The resultant of which pair cannot have a magnitude of 4 Newton. See here, it is given like that, having two vectors A and B. A and B are having some angle theta and theta is unknown, right? A bar, B bar, and it is having some kind of magnitude. Let's change color. It is having resultant. It is like that, right? So this resultant should not have 4 Newton, right? Since theta is not given, so therefore we need to consider R as a maximum value or minimum value to just find out the range of the entire R. So what is the equation of R? That is R is equal to under root A square plus B square plus 2AB cos theta. This is our equation. This is our equation, right? So we know that when theta is equal to 0, cos theta is 1. That means R is equal to A plus B, that gives us maximum. And similar when theta is equal to 90 degree, cos theta become 0. And for the negative part, opposite part, that should be theta is equal to 180 degree. That means cos theta become -1, and ultimately you can get minus. So R mean we can get A minus B. And we already studied this part, so we are not spending much of the time in this calculation how we got this. Right. So let's check where the values R maximum is equal to A plus B and R minimum is equal to A minus B. So to find the entire range, for the first case, case number 1, where it is mentioned 2 Newton and 3 Newton. So we know that that is the value of A, that is the value of B, and for the minimum value A minus B, that means 1 Newton. So R can have 1 Newton and the maximum value R can have 5 Newton. So R can have in between 1 to 5 of this range, and can we say 4 falls in between 1 to 5? If 4 is in between, that means what is mentioned here? The resultant of which pair cannot have a magnitude of 4 Newton. So resultant, definitely it is having 4 Newton at some angle. So first result is incorrect. That case number 1 is not correct one. So let's check case number 2. What is mentioned? A is 3, B is 3. So A minus B is equal to 0 Newton and maximum is 6 Newton. So values of ranging from 0 to 6 and 4 is definitely in between. 4 is definitely in between. So this answer is also not correct. Let's check case number 3. So A is 2 Newton, B is 6 Newton, minimum will be 2 Newton, maximum is 10 Newton. So yes, suppose R can have 4 because it is in between maximum and minimum value. So this answer is also incorrect. Let's have case number 4. A is 3, B is 8, A minus B 5 Newton and maximum 11 Newton. So therefore 4 is outside of 5 and 11, and therefore this become our correct answer. So answer number D is correct one. Example number 8. What is mentioned here? The magnitude of the resultant of two vectors. So here we consider vector number A, vector number B. What is mentioned? Both the magnitudes are equal. That means, say for example, it is having A magnitude and the B is also having A magnitude. Right? So both are having A magnitude is equal to the magnitude of either vector. That means it is a resultant magnitude is also having similar vector, similar, and that also become A. At what angle? Find the angle between the two vectors. Right. So we know that equation resultant is equal to under root A square plus B square plus 2AB cos theta. Here it is mentioned A is equal to B. So let's take A, as well as resultant is also A. So let's put the data. R is equal to A square is itself A, B square become A square, 2AB become 2AA, that means 2A square cos theta. You can write here A is equal to under root 2A square plus 2A square cos theta. We can take A square is equal to 2A square plus 2A square cos theta. We can send this side, opposite side. What become? A square minus 2A square is equal to minus A square. Can we cancel this A square? Of course. And therefore cos theta become minus 1/2. If it is minus, then which angle? Which quadrant is required? Tell me. Second, the correct answer, yeah. So theta become 120 degrees. So at the angle of 120, say for example, this is here and another is A, this is B vector, both are having similar magnitude, angle is 120. So that resultant is also equal to magnitude A, is also equal to magnitude A. So at 120 degree, all three vectors means two original vectors and its resultant all are having equal magnitude at 120 degree. Example number 9, if A plus B, mod A plus B is equal to mod A minus B, the angle between vector AB is, what is the angle between this vector? So we know that A plus B mod A plus B is equal to root A square plus B square plus 2AB cos theta. And for A minus B, here it is minus, so put it minus here, A minus B, A square plus B square is equal to A square plus B square minus 2AB cos theta. So here given A plus B is equal to A minus B, it is given. Put the values here and let's remove square power, or simply when we say both the equations are equal, that means this portion should be equal, and ultimately cos theta must be equal to minus cos theta. When it happen? When cos theta both are 0. Otherwise, both are not equal for any other degree. It should be 0. Right. And when it becomes 0, when theta become 90 degree. When theta become 90 degree, then it becomes 0. Now you should pause the video and solve this question. Question number 5, two vectors A is equal to 2, B is 5 are at an angle 60 degree to each other. Find the magnitude of their sum and differences. Similar examples we already solved. You can have A plus B equation and as well as A minus B equation that we already know. Under root A square plus B square plus 2AB cos theta, and here for that just become minus 2AB cos theta. Very simple. You solve this and comment in the section your answer. Second is find the resultant of two vectors. A is 4, B is 3, and from the figure, right? From the figure. So we need internal angle. You need internal angle. What should be internal angle? You know that 100 minus 60 minus 30. I think this hint is sufficient for you to solve this. We studied different methods. Now let's see a resolution along a rectangular component. Easy method and it is very convenient. So here we know that a coordinate we consider x, y and z for the 3D and only x and y for the 2D, for the 2D consideration. Here if you see this I, so it is a unit vector. It is a unit vector along x direction. J, it is presenting unit vector along y direction, and k, it is presenting unit vector along z direction. We know that a cap is used for the symbol I power cap. It is used to show a unit vector. We already studied what is unit vector, so no more detail is required for that. So this is very convenient when we go with a rectangular coordinate by using a Cartesian coordinate system. And the different Cartesian coordinate systems according to right hand rule, we will understand also what is right hand. So there are, in general, we use majorly A number. There is a B is also available as well as C is also available. Mostly we go with A as a Cartesian coordinate system. So now let us start with resolution with a 2D only. So here if we need a resultant, we could write R or we write F or we write whatever, right? Depending on our application. So this is a resultant. Say for example, this angle is theta with respect to x. So we know that if I just want a component along x direction, so there are two sides. We know that sine theta is equal to opposite side, this side, opposite side divided by its hypotenuse. Similar here, if I need this side, so I need cos theta is equal to this side, which is f of x divided by hypotenuse f. So ultimately, we can find f of x is equal to cos theta, which is multiplied by f, and f of y can become f cos theta, but here it is x, here it is y. So we can consider the component, and this become very convenient to resolve this all the solutions or to get resultant one, or we can consider only single theta, so in which f x become cos theta and f y become sin theta. We know we are very much aware of this part. So ultimately we can get f is equal to f cos theta I representing x direction, f cos theta y, or you can have this as a theta only, so it becomes sine, it represents j direction. We can take like that, and ultimately we can find magnitude f under root fx square, this component square plus this component square, and ultimately we can have solution. We will solve many examples, we will understand this very well. And if we need a tan theta, so we know that it's the opposite side divided by a nearer side. So the opposite side divided by nearer side. And if we need to have an opposite angle, so this is the equation for the opposite angle. Let's solve example number 10. What is mentioned here? Resolve a vector into x and y component. The magnitude of a is 4 units. So here the value of unit is given 4. And to solve this, what we need to have two components. One component becomes here, we can say f of y, and angle is not given this one, so f of y will become sine theta, and another one, this case we need, and that become f of x, so that become a, we need to put here a cos theta. It is simple part. So here for the x direction, we need to understand in which cos become negative. So we know that this is a method to know in which quadrant, which coordinates angle become negative or positive. So if it is in the first quadrant, angle it is in first quadrant, so all should be possible. That means sine or cos or tan, whatever, all the solution answer is positive. If it is a second quadrant, so here only sine, angle sine gives a positive answer. In case of quadrant number 3, only tan gives positive answer, all other are negative. In case of quadrant number 4, only cos gives positive, all other gives negative. So here in the first case, a of x, it is angle 180 minus 60. Therefore, it falls under second element. Sine is positive. Therefore, answer it is negative. Therefore, answer is negative. And x, a of x, it become minus 2. We can also judge that direction is opposite, so therefore answer is negative. Therefore answer is negative. That can also be an answer. Similar for y, what will become? A sine theta. In the second quadrant, sine is positive, therefore the value should be positive, and 60 is equal to root 3 by 2. So we have become 2 root 3. Let's say for the B. Let's say for a drawing number P. So this is along x direction, that gives fx, and that gives f y. What is the equation of f of x? Is equal to a angle is nearer, so become cos theta, a cos theta, and here become a, yeah, great. So in the x direction, that is a cos 30, and this is the fourth quadrant. This is the fourth quadrant where cos is positive, therefore answer is positive. And that become 2 root 3, and for the y, that is the fourth quadrant, sine is negative, so minus a sine 30 and become minus 4, that is 1 half. So ay in the y component, that become minus 2. Very simple. Let's move. So similar resolution in the 3 dimension we can do. We just need to have component along x direction. I represent unit vector. Similar y component along y. J represent unit vector. Component along z, and k represent unit vector. So ultimately our answer will be f is equal to f of cos with respect to angle with respect to x, angle with respect to y, angle with respect to z. We can solve this conveniently, and ultimately it gives us a result. Now next is addition and subtraction of vectors. So we know that. Let us assume vector A is equal to this one, and vector B is equal to second one. Now see, addition and subtraction is very easy. A plus or minus B, whatever sign holds by A or B, you just keep as it is. So ultimately you just need to have addition of I, that means it representing x direction. So only addition of x is required here, addition of y. For the j, addition of, or maybe a subtraction, whatever direction it is there, you just keep the same direction of x, y, and z. So it is very simple and convenient to have addition. And if we need a mode, so we already studied, it's a resultant that become, this is ax square final, ay square, and this is the resultant of this square. Very simple. Let's have an example. Obtain the magnitude of 2a bar minus 3b bar if a is equal to I plus j minus 2k. That means it is 1i and 1j. And b is equal to 2i plus j minus 3k. So what should be our 2a minus 3b? So here 2a, that means 2 multiplied by a, I plus j minus 2k, that we put here, minus 3 multiplied by this b put here. And we know that when we multiply a scalar quantity with a vector, so you just have a scalar times vector, nothing else. So first one, let's solve I. First one, I portion, this portion. So it become 2 minus 6 of I. Similar for the j, For j, 1 multiplied by 1, that becomes 2, then minus 3 j, and similar we can solve like that. Here 2 multiplied by 3, so become minus 4, then minus 3 multiplied by minus 3 become 9. So our final solution that become this is minus 4 square, that is minus 1, and that become 5. So what is your answer? What is the answer? Comment me in the chat box. Now the dot product of a vector. This is very important. Dot product and cross product. We have been waiting for that, and now it's here. Dot product, it is also known as a scalar product. Dot product is also known as a scalar product. So what is mentioned in the definition? The dot product is magnitude of one vector times the magnitude of the projection of the second vector onto the first vector. So definition, don't worry about definition. Let us understand here by taking example. Say for example, there are vectors P and Q are mentioned here. Vector P and Q. And what is dot product? Dot product, it is a projection. If I take a perpendicular line from vector P, this is, so I can find projection of vector Q, that become Q cos theta. We know trigonometry, right? So here it is just a product of Q cos theta multiplied by P. Or you can take opposite side, take projection of P on Q, so it gives us P cos theta. So it is a multiplication of P cos theta multiplied by Q. P cos theta multiplied by Q. In both the cases, we are not taking direction. Here only magnitudes are taken. Therefore, final result become mode of P, mode of Q multiplied by cos theta, and therefore result of dot product is always a scalar product. Result of dot product is a scalar product, and it is not having any direction. See, no direction. It is not towards P, it is not towards Q. It is just a multiplication of, it's a vector times magnitude of opposite projection. It is just a projection of two sides. So here P dot Q is equal to PQ cos theta, and that become a scalar product. Now in sometime exam, you may have some questions that component of B, or let's just move here A and B. So what it mentioned, component of B along A bar. So you just need to take projection. Component of B, that means its projection. That is what? That is B cos theta. That is B cos theta. Right. So we know that A dot B is equal to A mod B cos theta. Right. If you just take cos theta, B cos theta in a single side, so B cos theta mod B is equal to A B vector divided by its mod A. Similar here, this is A B vector divided by its mod A, and we know that A vector divided by its mode, so it gives us unit vector. Right. So ultimately, projection of B, it's a projection in a unit vector A. Similar for the component A along B bar, you can prove that part. Right? Ultimately, we need this one. So this is component of B bar along A and A bar along B bar that you have to work out. Now next is properties of dot product of two vector. Here it is very important. You can find several questions based on this. First is the property of commutative property. That means order of matrix does not matter. It is mentioned here. A dot B is equal to B dot A. A dot B is equal to B dot A. The values are not going to change. Whatever values are here, left hand side, if I change the order, it is not affecting the final result because A dot B is equal to AB cos theta and B dot A is also AB cos theta. So it is not changing its value, and that property is known as commutative property. Remember, you may have some questions based on this. So dot product is having a commutative property. That means order of matrix does not matter. You can have any order. Result is similar. There is no change in the result. Second property, it is a distributive property. Distributive property. From the word also understand there is some distribution part. So numbers, or you can say vector, can be distributed to all other. Example is given here, A dot B plus C. So that A can be distributed like A dot B with the first component as well as with the second component. So A dot B plus A dot C is possible. So that become a distributive property. Say for example, here it is A dot in bracket B plus C plus D. So you can write A dot B plus B dot C plus C dot D. Is it okay? Is it okay? No. It should be A dot B plus A dot C plus A dot D. This is correct. Right. So this is a distributive property. The number can be distributed to all like algebraic. Then next is a binary property. A binary property. A vector can be assigned to each of the pair of the element. Say for example here it is A dot R. If it is not, R is not a board, so that means it is a scalar. So we can have R, you can take outside, that is okay, and it give A dot B. The distributive property will work here, A dot C. And scalar you can take outside, or scalar if it is inside, then also there isn't any issue. So you can move scalar in the case of a bilinear property. It is a bilinear property. So I think mispronounced. That is known as bilinear property. Next is scalar multiplication. If there is a scalar, x small x is a scalar value, small y is a scalar value. So you can directly multiply x multiply by y, and you can have A dot B. So scalars you can have similar to algebraic property. There isn't any difference in the property of dot product, or simply you can say algebraic property. See, ultimately dot product is a scalar property, so all the algebraic properties are here applicable. And then next is parallel. If two vectors, for example A and B, both are having a parallel vectors, this is A, this is B. Two possibilities are there. Either it can have, here it is 0 angle, and here it is 180 degree angle. Theta is 0, theta is 180. So we know that equation A dot B is equal to mod A mod B cos theta. So when cos theta is equal to 0, cos theta is equal to 0, that means the value is 1. And in this case, AB, it gives maximum value. So when two vectors are parallel, in the opposite direction also, it always gives us maximum value. It gives us maximum value, right? So A dot B maximum value is equal to always mod A mod B. Both the magnitudes are multiplied, right? Because projections are the 100% projection is visible on the opposite side. The next is orthogonal. Yeah, this might be a new word for you. Orthogonal, that means a perpendicular. Simple meaning is that orthogonality, that means a perpendicularity. Suppose a vector A, this is vector number A, and this is vector number B. Now in this case, what is angle? Angle become 90 degree. Angle become 90 degree, and therefore the projection of B, if we consider, then the projection of B is 0. Therefore A dot B, that is 0. Or ultimately you can see cos theta, that become cos 90, and 90 cos 90 is equal to 0. Right. So this orthogonal property is more important. You may have few questions on that, and we know A dot B is equal to 0. A dot B is equal to 0. So that we need to understand, in a detail. Now next is the scalar product or dot product. Suppose a vector, it is having a1 magnitude and I presenting it's a unit vector along x direction, a2 its magnitude, and j representing a y direction. And another b, it is there b1i plus b2j. It is a similar case here. How to do a dot product of a scalar? Right. This is our question. So there is a method in the mathematics called FOIL, FOIL method. It represents F is for first, O is for outer, I is for inner, and L is for last. That's all it. So A dot B, let us consider the first component, that is the multiplication of first to first. So that gives us A1, B1, I multiplied by I. Right, I multiplied by I. Then outer, So outermost, this is outer, and that is outer. So what it gives? A1, outer is B2, I, J. A1, B2, I multiplied by J. Right. Just to avoid cross, we just put here dot. Fine. Then third, it is inner. Let's have another color. This is for the inner. It's two inner portion. So this become inner and this become inner. So A2 B1 J I. A2 B1 J I. And the last. This is a last. A2 B2 J J. I think you understood this very well. Now, when we talk about I dot I, that means what? This is I along x-axis, another I along x-axis. So therefore, theta is equal to 0. And we know that cos theta, when it is 0, it become 1. That means I cross I, I multiply I, it become 1. So for the parallel, it become 1. And when when we consider I multiply by j, so this is I and that is j, and theta become 90 degree for the Cartesian coordinate. And we know that cos 90 is equal to 0. Cos 90 is equal to 0. So what happened? Here I dot I, that become 1. Similar j dot j become 1. But what about ij? Ij, that is a 0. Ji, that is also 0. So finally we just need to have a1, I become 1, jj become 1, and that is a1 b1 a2 b2. And during calculation of dot product, you may skip this rate and you can directly write this. So in the case of dot product, the multiplication of a, right, a b1 and then this one a2 b2, only its single component with I multiplied by I, j multiplied by j, it is just required. So remember that part. Let's solve example. Find the dot product of a is equal to 1, 2, 3 and b is equal to 4, minus 5, 6. And what kind of angle the vector would form. Let's see. So formula of the dot product, and we know that a is equal to 1, 2, 3, b is equal to 4, 5, minus 5 and 6. And dot product, it is equal to, that is a1 b1 plus a2 b2 plus a3 b3, that is dot product. A is equal to 1, b is equal to 4, a1 1, so multiply this to, another is multiplication of 2 minus 5, and this one is 3 multiplied by 6. So we can have solution, it is 12. A dot b is equal to 12, a dot b is equal to 12. And you comment me what kind of angle the vector would form. Comment me in the text. Example number 14, two vectors a and b are given. So a, see, you can write vectors in the form of this bracket, or you can write 2i minus 3j plus 7k, like that. Find the dot product. We know that the method is like that. Here the similar equation is to be followed. 2 multiplied by minus 4, right? Then 3 multiplied by minus 3 multiplied by 2, that is the solution. And here 4 multiplied by minus 4. So ultimately it gives us minus 42. Solution is minus 42. Vector dot product gives a scalar. Dot product gives a scalar. Right? Let's have example number 15. What is mentioned? If the vector p is equal to a 3, q is equal to a minus 2 minus k, perpendicular to each other, find the value of a. So see, when there are perpendicular, so we know the dot product of vector, that becomes 0. Dot product of the vector, that becomes 0. So that means vector dot another vector is equal to 0, and we know that multiplication is a square. This is minus, right, multiply by this j. Ultimately you will get the solution is equal to that, and you can find solution. A is equal to minus 1 comma 3, b is equal to, like that. Similar solution you will have with you. And example number 16, you try both the examples by yourself. I am just showing here. Find the component of 3i. We know what is component. This is vector a, vector b, and the component of vector theta b on a, that is b cos theta, and opposite is, for opposite it is become a cos theta, right? So similar, we already seen this equation, a bar b bar divided by its a b mode, and you just need to find out its a mode. Mode means 3 square plus 4 square, right? So you get answer like that, and that is your answer. You solve both the examples, are very simple, and you can get your answer with this. Now, example number 17. Find angle between this two. Find angle between these two. So here we also have another equation, cos theta is equal to a dot b dot divided by ab. Put the values here and you will have your solution. You also try this example by yourself, not spending much of time on that. That become your homework problem. And this question number 6, determine the dot product and the angle between the vectors. Two vectors are given, so this is your homework problem. This become your homework problem. So pause the videos and what I suggest that you solve this 4 examples. You should solve this 4 examples now. One more, question number 7. F1 is equal to 5i plus 4j plus 3k and F2 is equal to 4i minus 2j minus 4k. Show that F1 and F2 are at right angle to each other and you can use the orthogonality property. What was orthogonality property? You just go back to certain slide so you will understand. A dot B dot is equal to some value, it was there, 0 or not. Solve it. You can do it by yourself. And one more question we have, determine the projection of force. We just need to have projection of force. Projection we already understand. This is A vector, this is B vector, so that is known as projection. B cos theta, that is the projection. That is the projection. Solve this example and put your answers on the comment section. So let's say a very important question. If you see our initial stage, we have seen some scalar and vectors and this part was skipped over there. So one question is that why work done is a scalar product. First, what is a scalar product? And a dot product of any matrix, what it gives? A dot product is a magnitude of one vector. See the word you understand here, magnitude. Magnitude of one vector times the magnitude of projection. That means it is a multiplication of magnitude. And it is a multiplication of P and the projection of opposite one like Q cos theta. Therefore, ultimately, if there is a multiplication of magnitude, if it is just a multiplication of magnitude, that means it gives a scalar. Right? So, dot product of vector quantity is always a scalar, which means it has only magnitude and no direction. And therefore, work is equal to force multiplied by its displacement. It is a dot product. And therefore it has no direction. It has only magnitude and therefore it becomes a scalar product. If we apply force in the direction, so displacement, right? If it is in the same direction, so we can get 100% force multiplied by displacement. If it is in other direction, so we can have a third direction, but ultimately it does not give any direction for that, right? And so we use here magnitude of force and magnitude of displacement. Ultimately, therefore, work is not a vector, but it is just a scalar product. Let's have another example number 19. The object goes through displacement. The displacement vector is given. D is equal to 3i plus 1j meter, and the force is given 4i plus 2j Newton. So we know that force, what is the work done by the object? So we know that W work is equal to force multiplied by displacement. And the force vector, it has to be a dot product to get a final solution. So 4 multiplied by 3. We know that this method we already studied, right? The FOIL method we already studied. The first, that means the first is to be multiplied. This is the first is to be multiplied first. Then next is outer. So this is outer multiplied by outer, that gives this solution. Then inner, so inner multiplied by inner, so here it is inner. And the last, this is last. So this is last, so it become, we know this method, we had this method previously also. And we know that I multiply by I, that means axis, if it is axis in the similar direction, theta becomes 0 and cos 0 is equal to 1. Right. So only I of I, that become 1, but if it is I of j, I multiply by j, I dot j, so theta become 90 degree and cos 90 become 0. So it has to be cancelled out. So ultimately you just need to multiply with this I and 2 with 1. This green portion you may skip. This is only for our understanding. This here is only for our understanding. So work done is a scalar quantity because it does take magnitude of both the vectors. Example number 20, find the unit vector in the direction of vector A 3i plus j minus 5k. We just brought one example for a change in a unit direction. So we know that unit vector A is equal to vector A divided by its magnitude. Magnitude is equal to, it's a 3 square plus 1 square plus 5 square. You can get this answer and it becomes 35. So ultimately 3 divided by 35 root 1 by 35 root, and that gives us our solution. Very simple one. And this question number 6, do it yourself. Why this quantity is asked? Scalar quantity, one is power, which is having force, and the multiplication of velocity, to vector quantity, then current, J, current density multiplied by its area, and magnetic flux. Prove this and answer me in the comment section. Now we arrive the last part of the vector, that is the cross product of vectors. See, cross product, it is also known as vector product because it gives a resultant as a vector. What definition stands? It stands that cross product is a binary operation on two vectors in three-dimensional space. It results in a vector that is perpendicular to both vectors. Suppose there is a vector P, it is here, and at an angle theta, there is another vector, Q. So cross product of this vector gives multiplication of vector P with its a projection but on a perpendicular line, So projection of Q on a perpendicular line, that becomes Q sine theta. We know it's trigonometry, and that's why it's create entire area for the solution. So it gives us P multiplied by Q sine theta. Mod P, mod Q, sine theta. It is a cross product and it is taking area. So here P cross Q, that is a cross product of two vector. It gives area, and it is equal to mod P multiplied by mode Q, and the difference is here sine theta. And something you can see in the red color, there is a and. What is this? It's a unit vector. We'll see this unit vector little later. So here PQ sine theta is the area of a parallelogram, and which is a magnitude, of a cross product. And here n bar, it's a unit vector, and which shows a direction of a resultant vector, and which is always perpendicular to AB. That means AB or PQ. If we take this here AB vector, so here, and it gives just a direction. It can be upper side, it can be maybe opposite side. Both are possible, right? Negative, both are possible. We don't know which one is the correct one, but this n bar gives direction. Maybe in this case we may not write AB, but we should write PQ, right? So first portion, say for example, if you just have P cos Q, so it is always PQ sine theta plus something as the n bar. If you just forget this part, so Q cross P, it should be also PQ sine theta, and if you write this P cross Q is equal to Q cross P, then your answer is wrong. Reason is here direction. Here it is direction. Both are equal and opposite direction. Both are having equal and opposite direction, because here ultimately it gives us a direction which is perpendicular to PQ. That can be opposite side, upward side, or it can have in the whatever the direction it is there. Therefore, cross product gives us a vector quantity. So let us take here, say for example, there is a vector, it is having angle theta with B vector, and if we want cross product, so A cross B, it is perpendicular to both AB, that means AB plane, that should be perpendicular to both, and here it gives n vector for that. How to find this n? That can be a question for that. And for that, a right hand rule is useful. Right hand use is useful. So what did it say? Stretch right hand so that the index finger of the right hand is in the direction of first vector. First vector, if you are measuring A cross B, so first index finger should be in the direction of A. The index finger should be in the direction of A, right? Index finger should be direction of A, and the middle finger should be direction of B. In the middle finger should be direction of B, right? So such that thumb indicates direction of vector n. Let us understand. Say for example, I am finding vector in the direction of A, so you just need to put this finger, index finger in the direction of vector A, and middle finger in the direction of vector B. So thumb direction gives vector n direction, whether it is upward or downward, or two options are there, whether upward or downward. So this is right hand thumb rule. There is right hand thumb rule. It is also there, where you just need to have stretch your right palm, and you just need to close fingers in the direction of A to B. If it is A cross B, so cross this finger, close this finger, starting from A to B, right? Open position of hand to the, like that, open position of hand. You just close from, say for example, this is A and this is B. So A to B close, and this thumb, that thumb gives us direction. So we have here cross product of vector, and the first part, it is orthogonal unit vector. See, when we talk about unit vectors in this Cartesian coordinate along the x direction I, it is to be considered as a unit vector. Unit vector is only having direction. This represent only direction, and its magnitude is to be considered as a 1. And it is having some symbol like that I, and having cap. Someone has given a cap to I, j, and k. So I, it is unit vector along x-axis. J, it is unit vector along y-axis, and k, it is unit vector along z-axis. See, this I, j, and k represents its direction. Now let's resolve these unit vectors. First, if we vector unit vector I multiplied by I, it is a cross product. So we know that its a magnitude, or you can say product, become I mod I multiplied by sine theta. And let's have direction. Let us direction. Forget the direction. First, I, that means unit vector, and unit vectors are having magnitude 1. Again I multiply by 1. Now the theta, that means angle between I with I. So angle with I and I, that means both are at the same angle, and therefore theta is equal to 0 degree, and therefore sine 0, it is 0. Therefore entire equation becomes 0. Therefore entire equation becomes 0. So sine 0 is 0. Forget about direction. If it is a 0 vector, then there is no direction is required to consider. So therefore I product I cross I, it becomes 0. See, we have seen a similar case when there was a I dot I, and in that case it was 1, opposite to 0, 0, right? So in the dot product and cross product, majorly they function opposite. Similarly, we can derive for the j dot j. So we know that j cross j is equal to mode of j multiplied by mode of j sine theta, and the end direction. And this is angle with j, that means theta becomes 0 and sine theta becomes 0. Therefore j cross j, it is 0. And similarly for the k cross k, let's have cap. So angle of k to k, again it is 0. So sine theta becomes 0, and therefore k and k also becomes 0, right? If you see, we have seen this case, I dot I is 1, j dot j is also 1, and k dot k is also 1 in case of dot products. Now, next is, if we take product of I, that is the I with respect to j. So if we take I cross j, so is equal to, we know that mode I mode j multiply by sine theta and direction. Let's see, and direction what is. So see, angle between I and j, we know that that become 90 degree, and therefore I is equal to 1, j mode is 1, and sine 90 with some direction, And what is sine 90? Sine 90 is also 1. Therefore I cross j is equal to mode n. It becomes mode n. Now here, to identify the direction of n, we required our right hand. So take your right hand, and this finger, index finger, it should be in the direction of, if we are finding I cross j, so that index finger, that should be in the direction of I, or we can say in the direction of x, because I represent x direction. And a middle finger, do not show middle finger to anyone, but here we have to show middle finger to a y direction. So this is y direction is j, and j representing y direction. Right? So in this case, this thumb is going in this direction. Thumb presents n direction, means it's a cross product vector. It is represented by thumb. So thumb direction, it is showing what? It is showing direction z, and z it is presenting k vector, and therefore n cap become k vector. N cap become k vector as per right hand rule. So I is 1, j is 1, sine 90 is 1, and n cap become k cap. Therefore, I cross j become k cap. It is very simple. It is right hand side rule. Then next is, let us consider another one, j cross k. See, j cross k we are taking, its order is important. First j is coming. So what we have to do? We have to take again our right hand, and this index finger should go in the direction of j, or we can say j is showing y axis. And the first finger should be in the direction of k. First finger should be in the direction of k, so it is going in this direction k along z axis. And here the thumb, this thumb is showing direction of the resultant n vector, and is equal to I, which is showing x direction. Therefore here this resultant vector become I. J is 1, k is 1, sine 90 is also 1. We know that angle between j and k is 90 degree, because x, y, z all are mutually perpendicular to each other, and therefore j cross k become I. J cross k becomes I. And similarly, we can derive relation between k and I. K and I both are perpendicular to each other. You take your right hand, do it yourself, and yes, you post your video or your solution for this k cross I. Are you getting the similar result or not? Let me know. See here, if you just want to have a simplified version, for that, every time we do not to go for a right hand and to find axis, it is very simple. You just draw a circle, which is first I, then put an arrow, then j, then k. Here we are moving from I to j, so we can show I cross j is equal to the third one, that is k, So we can see here, similar, we already derived in this case. For the next one, if you move from j to k in the same direction, means j cross k. See, first is coming j and second is coming k, right? So next equal is become I cap. So we have seen this one also here. And for the third case, k cross I. So first k, then I is equal to j, right? So from the circle, this circle, we can identify solutions easily. See here, if we opposite directional movement is taken, say for example, if we are taking all of this direction opposite, first if we take j cross I, see, direction is very important when we talk about cross product. So we are moving from j to I in the opposite direction, so we are getting here k, but here k is minus k. If you move in the opposite direction, so we are getting negative result. Similar for the k, if you move from k to j. So we got I. So k cross j. We are running in the opposite direction. So is equal to minus I. Minus I. And for the last I k. Let's erase I k. If you see the direction which is opposite, rotating. So I cross k is equal to minus j. I cross k is equal to minus j. So this is very simple method to remember, right? This is very simple method to remember this part. Now, let us first understand various properties of cross product of a two vector. See, first property, it is very well known to us. If this is, say, for example, our vector A and this is vector number B, so it's resultant vector, right? It resultant vector because of A cross B, it is always perpendicular to both A and B. This is always perpendicular to both A and B, and we know that that is n cap. It may be upper direction or maybe in the opposite direction. That we can get from right hand. That we can get from right hand. So first property, it shows that, right, a vector product of two vector is always perpendicular to plane containing two vector, right? So it is always perpendicular to this plane. It is very well known. Second is non-commutative property. What is meaning of non-commutative property? What is mentioned? Order of matrix is important. We have to follow order. That means, see, A cross B, if you put A cross B is equal to B cross A, so that statement is incorrect. In the case of two vector cross product. Two vector cross product, right? We have studied other than normal calculation, other than this vector. So we know that A multiplied by B is equal to B multiplied by A, but here it is not applicable when it is a cross product. Reason is that, what is the reason behind that? Because it become A cross B is equal to minus B cross A. Reason is that A cross B is equal to AB sine theta. This portion is magnitude is okay. There is no problem with magnitude, but here the direction matters. When we talk about A bar, B bar, its resultant is perpendicular to N bar. When we take A cross B, but if we take opposite one, B cross A, direction flips, right? So therefore, A bar, this is N bar, is not equal. If we take B cross A, if we take B cross A, that become negative. That become negative. Magnitude is equal, but the direction is opposite. Direction is opposite. In this case, therefore, this cross product of vector is not equal, and therefore this property is known as non-commutative property. Second is distributive property, how the products are getting distributed. Like that, order of vector is strictly mentioned. Say for example, if it is A cross B plus C, example is given A, here cross product is given B plus C. Yes, we can have A cross B plus A cross C, but we cannot write B cross A plus C cross A. We have to follow strictly its order. So yes, of course it is having distributive property, but here order has to be mentioned exactly in the same manner which is mentioned. Next is a scalar multiplication product. If you multiply the product vector with a scalar, so say for example, A is multiplied by this is scalar x, and B vector, it is having multiplication with scalar unit y. Scalar, it is not having any direction, it is just having magnitude. So ultimately we can, both the x and y, we can throw them out. We can have a product of x cross y, x multiplied by y, that is for the scalar, it is no dot or no cross product, both are equal. And we can write A cross B. Similar, if it is having some constant, say for example A bar cross B, B bar cross C bar, ABC, if we see the constant, so we can write A multiplied by B multiplied by C, and we can write A bar cross B bar cross C bar. This is possible. This is very well possible. If you observe this result, so if you may compare this with matrices, matrices possess the similar property. There is no change in the property of matrices if we compare with this. Let's move. Parallel property. Parallel property means what? If we can say A and B, these are two vectors, are having 0 degree angle. If A and B both are having 0 degree angle, so we know that ultimately it's a product is a multiplication of this two and it produces area. It produces area. If there is no area, that means its answer is 0. Its product is 0, right? And we can see here also sine theta, sine 0 is equal to 0. If it is 180, then also it is 0. And therefore, if it is mentioned that vectors are parallel, therefore at A cross B, vector A cross vector B, it is always 0. See, there are so many examples you will find based on this rules, and therefore these rules are very much important. In the examination of JEE NEET, you will find this kind of rules. And the last property, it is orthogonal. Orthogonal you will see many a time. Orthogonal, that means it is just showing a perpendicularity. Orthogonality, that means 90 degree property, 90 degree property, it is showing 90 degree property. So here, if you talk about two planes A and B, and here mentioning that this angle, if it is 90 degree, then what? See, so we know that it gives sine theta, and if it is sine 90 degree, if it is sine 90 degree, we know that sine 90 is equal to 1. So we know that this sine 90 is 1, that it become 1, and therefore A cross B, it gives a maximum. A mod, B mod, its maximum value can be achieved when vector is orthogonal, vectors are orthogonal, that means it is making 90 degree angle, and A cross B is equal to AB. If you see here, if you remember, for the parallelity A dot B, it was maximum, means mode A mode B dot, right? And when there was a both are parallel, and A dot B is equal to 0 when both are perpendicular. So you can see here there is an exact opposite property. It is having exactly opposite property. When we talk about dot product, here we are getting exactly the opposite property. See, these properties are very much important to solve various questions. And in the NEET and JEE examination, when you are talking about physics, the questions are tricky always, and people lose maximum marks in the physics section. And the reason is that because questions are tricky, 2 and 3 different concepts are merged, and the new examples are created. If you don't understand the concepts, these are the small concepts, right, thoroughly, then definitely you are going to lose marks. But stay with me, we will not lose any mark. Now let us have few examples. See, solving example is the best method. Solving various example is the best method to crack this kind of examination, to understand a particular topic. So here A is given, A is equal to I minus 2j plus 4k, and B is given 2I minus j plus 4k. So if we want to solve this, what we required, this is our first value multiplied by this, first value multiplied by second, first value multiplied by third. So AB cross, the first one is I multiplied by 2I, that become 2I cross I. Second is I multiplied by minus j, so minus 1 I cross j. See, I, that is the first letter coming, so I cross I cross j, and I cross k. See, sequence is very much important. Sequence is very much important. Then next one, 2j multiplied by first one, second and third. So become 2j multiplied by 2I become minus 4ji. Direction we have to take, right? Second is minus 2j multiplied by minus 1, so become 2jj, and minus 2 multiplied by plus 2, so become 4jk. And the last one, let us take last one, that is a 4k plus 4k. So multiply 4k with 2i, 4k with minus j, and 2k. So 4k multiplied by 2 become 8 k over 5, because it is first is coming k, so k cross I. Second is 4 multiplied by minus 1, so minus 4 k cross j, and the last one is 4k multiplied by 2k, so it is 8 cross a. So here we have to have knowledge of that when we multiply by k cross k, or I cross I, or j cross j, it becomes 0. It is 0. It is 0. Very opposite to the dot product. So here this is 0, this becomes 0, this becomes 0. It is not required here. Then we know that we have knowledge of circle I, then j, then k, and again moving to I. So I cross j is equal to k. J cross k is equal to I, and k cross I is equal to j. But if we move in the opposite direction, so here j cross I is equal to minus k. Similar, k cross j is equal to minus I, and I cross k is equal to minus j. We need to put this all values here, and therefore we require. So then ij, that become k, ik, ik is here, so it become minus j. Similar, you can put for ji. For ji it is minus k. jk is become I, ki, it is ki is equal to j, right? Ki is j, and next is kji, that become minus I. So you need to put this all the values and just find the solution. A cross B is equal to 10j plus 5k. Seems difficult, yeah, it is taking too much time. So go for vector. Vector is very simple to represent this equation, and you should go for vector for a simple solution. Suppose A cross B, if it is given, so what we should do? We should take first row ijk, and then next here, that is first A, that is 1 minus 2 4. Put here 1 minus 2 4, and this is the third row, it is showing B, that is 2 minus 1 2. Put this value here, and let's solve this vector. So to solve this vector, what we need, we start with I. So hide this row and column, and then multiply minus 2 with 2, then minus in bracket minus 1 minus 4, so become minus 4. Similar, j. So then next is minus j in bracket, hide this row and column, then multiply 1 with 2, so that gives us 2, minus multiply 3 with 4, so it becomes plus k plus we have here k. So k in bracket, hide this to cross 1 minus 1. So become minus 1 minus in bracket 3 multiplied by minus 2 become minus 6. Simplify this, you will have solution. Simplify this, you will have your solution. So I is equal to minus 4 minus in bracket minus 4. You can get like that. Dissolve this, becomes 0. I plus 10j plus 5k. So this is our solution. This is our solution. Very simple when we go with matrices. So A cross B is equal to 10j plus 5k. 0 of I is not having any value. Therefore, we can remove this one easily. Then example number 22. Find A cross B if A is equal to 2i plus 3j plus 4k and B is equal to 3i plus 2j plus 3k. Let's put here A is equal to 2i plus 3j plus 4k. B is equal to 2i plus 2j plus 3k. We can put here. What next? Matrices. Put A is equal to 2, 3, 4. 2, 3, 4 here. B is equal to 3, 2 and 3 here. Now what next? What next? I. So I is here. Hide this row and column. 3 multiplied by 3 become 9 minus 4 multiplied by 2 become 8 minus 4 multiplied by 2 become 8. Now next is minus j. Hide this row and columns. 2 multiplied by 3, 2 multiplied by 3 becomes 6. 3 multiplied by 4 become 12. Similar k. Similar is for k. Hide this row and columns. 2 multiplied by 2, 4 and 3 multiplied by 3 that will become minus 9. It is very simple. Solve that. That is the answer. Solve that. That become answer. So I plus 6j minus 5k. That is our answer. Let's solve one more. Example number 23. Determine the magnitude and direction cosine of the resultant vector. So we need to here get magnitude as well as direction. So for that, first this is A is given 4i plus j minus k and B is given 3i plus 2j plus k. I think you should pause the video here and first you should find it's a product A cross B. We know that A cross B is equal to put I, j, k, value of A 4, 1, minus 1, value of B 3, 2 and 1. See, you cannot reverse or you can say you cannot change this matrix, otherwise answer will be wrong. I, for the first I, multiply 1 multiply by 1 minus minus become plus and that is a 2 multiplied by minus 1 become 2. Second is minus j, hide this row and column. 4 multiplied by 1 become 4, minus minus become plus 3. So 4 plus 3. And the last one is k. So hide this 2, 4 multiplied by 2 become 8 and minus 3. We may simplify this here. So finally we get 3i minus 7j plus 5k. That is the solution. Now we need magnitude. That means we need to have square of 3 that become 9 plus minus 7 square become 49 and 5 square become 25. Solution is 9.110. But here we also need its angle. So we know that A cross B is equal to AB sine theta. That we know how it works. Here we need a sine theta, so we can take sine theta aside. Sine theta is equal to mod A cross B. That answer we already have. But now we need to find answer for mod A and mod B. These two answers are required to get. And how? Again, take mode A. So here it is 4 square 16, 1 square and 1 square ultimately become root 18 and it is 4.23. And similar for mode B, we get 3 multiplied by 3 become 9 plus 2 multiplied by 2 become 4 and plus 1. So ultimately it is root 14. You can get 3.74 as an answer. Put these all the values in the above equation and you will get sin theta is equal to 9.11 divided by 4.23 multiplied by 3.74 and answer is theta is 35. Theta is 35. So it's a very simple question. Let's go to another one. If A bar is equal to 5, B bar is 6 and A bar cross B bar is equal to 15. Direct answers are given. Find the angle of A cross B. In the examination, you will be having four options. So you can find out one out of it. So sin theta is equal to product of that is given 15. A cross B is also given. We can solve this. So ultimately sin theta is equal to 1/2. We know this answer. This is very simple. And what about sin theta 1/2? So it is sin 30 degree. It gives sin 30 degree. Sometimes you will have very simple question also, or simple questions build the basics. We should start from simple examples and then we should move towards difficult one. And then example number 25, here A cross B is equal to A dot B. You may ask that, is it possible? Yes, of course it is possible. Let's solve this. Do we know A cross B? Yes, A cross B is equal to AB sin theta and A dot B is equal to AB cos theta. So it is given A cross B is equal to A dot B. Let's put the values of A cross B here and A dot B here. So what happened? A cross B sin theta is equal to AB cos theta. Let's cancel out this. So sin theta is equal to cos theta and ultimately sin theta by cos theta become 1. Sin theta divided by cos theta, that become 1. So it is tan theta. And when tan theta is 1, answer me. 45. Yes, yes, yes. Answer is correct. Answer is correct. So this kind of question you may find the examination also. And let's have another question. If A is equal to 2i plus j plus 3k and B is equal to I plus 3j plus 4k and it is given here A dot A cross B. See, whenever you find such kind of question, do not directly go for a solution. Just think about that A cross B. So this A cross B, that means what? Say for example, this is A, this is B, and let us assume some value of its cross product. When its cross product, let us say C. So what is C is equal to A cross B, which is always perpendicular to this A and B. That means perpendicular to A and B. And if you see this question, so it is asked that this A cross B, we assume that it is C and that is C is showing here. This is C. So A dot C. So both are having 90 degree. And when we know that A dot C orthogonal property, A dot C orthogonal property, when there is an orthogonal property, right? So it is having cos 90 degree and therefore A dot C becomes 0. A dot C becomes 0. No calculation is required for such kind of questions whenever you see, right? So CA cross B, the cross product of resultant vector is perpendicular to base vector. We already seen this is A bar, B bar, and resultant vector is always perpendicular to this. Maybe opposite side it can is also possible. And this is C, assume C is equal to A cross B, and C and A both are making 90 degree angle, and because of orthogonality property, we know that dot product of orthogonality means angle is 90 degree and therefore A dot B is equal to 0 and final answer is 0. Final answer is 0. So do not go and do not construct your matrix. First check for this possibility. You will find maximum time this kind of possibility. So you should save your time. for the other questions. Some of the questions are given that you should do by yourself. Question number 7, a is equal to I plus 2j plus 3k, b is equal to 2i plus k, and c is equal to this. And a dot b cross c, this data is given. You solve this and comment me your answer like that. Question number 7 answer, it is this, or you may comment the full method also. And question number 8, a dot b is equal to 0, b a dot c is equal to 0, then a is parallel to this solution. So which one is the correct one? This 2R you need to solve by yourself and comment me your answer. Do not Google your question. Definitely you will find your answer on Google, but you will never learn. Learning is only possible when you try by yourself. And you comment your answer or method, full method, in the comment box. So thank you for watching Physics Ka Doctor. My name is Dr. Ghanshyam Tejani. You may subscribe my channel. We will complete the full course of JEE and NEET. Stay with me. Thank you, everyone.